Hi, this is Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss the topic Shift Micro Operations. So, in previous classes, we have discussed about micro operations and their types. So, micro operations are the operations that are performed on the data stored in registers. And there are different types of micro operations are there. Register to register transfer micro operations, arithmetic micro operation, logic micro operation, and shift micro operations. So this is a last one. So shift, we are discussing shift micro operations. So shift micro operations that are used for serial transfer of data. So using this shift micro operations, we can transfer the data serially. And the contents of a register can be shifted to left or the right. So the data present in the register, we can shift to either left side or to the right side. So during shift left operation, the serial input transfers a bit into the rightmost position. Similarly, during shift right operation, the serial input transfers the bit into the leftmost position. Okay. So there are three types of shifts are there, that are logical shift micro operations, circular shift micro operation, and arithmetic arithmetic shift micro operations. So let's see one by one. So the symbol notation for the shift micro operations. So we are using different symbols for different operations. So the symbolic designation. So see here. So first one is a shift left micro operation. Shift left. So shift left register R. So we have a register. We have a register. Suppose if you consider a 4-bit register, inside the 4-bit register, it can store 4 bits of information: D0, D1, D2, D3. So something there is a data inside the register. So register is nothing but a group of flip-flops. So using that flip-flops, we can store the information. So that is a register. So the data present in the register, we can shift to either left side or right side, depends upon the operation. So first one is the shift left. So shift left. So that means the data present in the register, we are shifting to the left side. We are shifting to the left side. So that is a shift left micro operation. So the shift left we can designate with SHL, shift left, shift logical left. Okay. So that means we are performing shift left operation on the data present in the register R. After performing the result, again it will be stored in the register R itself. Next one, shift right. Shift right register R. So similarly, this is a right shift. So we are performing the right shift operation. So that means the data present in register, we are moving to the right side. So that is a shift right. So the symbol we are using is a SHR. SHR. That means logical shift right. Third one, circular shift. Circular shift left register. Circular. So circular means so circular. So inside the data present in register, it will be rotated in a circular fashion. Okay. So circular. So the data will be more circulated in a shift left. So in this direction. Okay. So that is a circular shift left and circular shift right. So circular shift right. Circular shift right. Shift right means here the data present in this will be moved in this way. Okay. So here in the circular shift right and shift left, we will not lose any data. So that will be that circular shift operation we can represent it with a CIL. CIL means circular shift left. Similarly, right shift we can represent it with CIR, circular shift right, CIR. And next one, arithmetic shift left. Arithmetic shift left register. So arithmetic shift left, it is similar to the logical shift left operation. So that we can represent it with a symbol ASHL, arithmetic shift left operation. And last one is the arithmetic shift right register. So here we are performing shift right operation. So ASHR, arithmetic shift right operation. So this arithmetic shift left and shift right we are using for the signed numbers. For signed numbers. For signed numbers we are using this arithmetic shift left and shift right operations. So these are the different shift operations, micro operations. So coming to the shift micro operation. So shift micro operations are used when the data stored in registers. These micro operations are used for serial transmission of data. So already we have seen. So the data present in register we are moving to either left side or right side serially. So here the data bits are shifted left to right or right to left. So either way we can shift the data. The micro operations are also combined with arithmetic, logic, and data processing operations. So mainly the shift micro operations are classified into three types, that are logical shift micro operations, next arithmetic shift micro operation, and circular shift micro operations. So these are the main classification. So in logical shift micro operation, again two types are there. So logical shift left micro operation, similarly logical shift right micro operation. Coming to the second one, arithmetic shift micro operations. Similarly here also again two types are there, arithmetic shift left micro operation and arithmetic shift right micro operation. And last classification is the circular shift micro operation. Here also again two types are there, circular shift left micro operation and circular shift right micro operation. So these are the main classification of the shift micro operations. So let's discuss one by one. First one is a logical shift micro operations. So the logical shift micro operations moves 0 through the serial input. So there are two ways to implement this logical shift. First one is a logical shift left and another one is a logical shift right. So let's start with the logical shift left. So here in this logical shift left, we are moving the data to the left side of the register. So each bit in the register is shifted to left. So shifted to left one by one in this shift micro operation. So we are shifting we are moving the data or shifting the data to the left side by only one position. For one operation, one position. Okay. So the most significant bit is moved outside the register, and place of least significant bit is filled with 0. So you can understand with an example. So we have a register, 8-bit register. So in that 8-bit register, there is a data 00001010. So that is a data. So this is a data stored in the register. So we are performing logical shift left micro operation. So that means we are shifting the data to the left side by one position. Okay. So see here, this is a LSB. So this is a register. So this is a register we are considering. So this is a D0, D1, D2, D3, D4, D5, D6, D7. So here D0 is the least significant bit, D7 is the most significant bit. So now we are moving the data to the left side. So that means see here. So D7 bit. So in D7 position there is a 0. So this 0 will move out of the register. So that means it will move to the out of the register. Next, in D6 position there is a 0. So that 0 will be moved to D7 position. So here 0. So this 0 will move here. So this 0 will move here. So this 0. Okay. So this 1 will comes to D4. So 0 will comes here, and 1 will comes here, and 0 will comes here. So here there is a vacant position in the LSB side. Okay. So that vacant position, it is filled with 0. So that means we are inserting 0 through the serial input. Okay. So before performing the shift left, logical shift left operation, the register contents are like this. But after performing shift left operation, the contents will be 0001. Okay, so sorry, here 1 will be there. Okay, 001, 01, 0, 0. Okay, so this is a data. So this is a before performing logical shift left. This is after performing. Okay, so in this way we can shift the data to the left side. So to implement the logical shift left micro operation, we use the symbol SHL. So SHL, if you specify SHL, it means we are performing a shift left operation, logical shift left. So we can write like this: R1, SHL R1. So that means we are performing shift left operation on R1 register, and after performing again the result will be stored in the R1 register itself. Okay. So this shift left operation is equal to it denotes the multiplication of 2. Okay. Multiplication of 2. So that means suppose if you consider a 4-bit register. Okay. So this is a 4-bit register: D0, D1, D2, D3. So that means this is let us assume some R1 register. So in this we have a data 0, 0, 1, 0, 1, 0. So according to the binary or 8421 code, its decimal value is 2. Okay. So suppose if I move this data to the left side, if I shift the data to the left side, then that result will be equal to the multiplication by 2. So that means after performing shift left, what will happen? So this 0 will comes to here, 1 will comes to here, 0. So here it is a vacant position. So that vacant position filled with 0. Filled with 0. So this 0, it will be moved outside, out of the register. That will move out of the register. So what is its equivalent to decimal value? So according to that, 2 power in binary, 2 power 0, 2 power 1, 2 power 2. So 2 power 2 means 4. So the its equivalent decimal value is 4. That means this 2, it is multiplied with 2. So we are performing shift left operation, means the result is equal to the multiplication with by 2. Multiplication by 2. Okay. Okay, so this is a logical shift left micro operation. And coming to the logical shift right. So here in the logical shift right, we are moving the data to the right side of the register. Okay, so see here. So this is a register. Okay, so you can see here. So this is a data. So that is a data present in register. So 0, 0, 0, 0, 0, 1, 0, 1. So that is the data present in the register before performing logical shift right operation. Okay. So logical shift right means we are shifting the data right side. We are shifting the data to the right side. So see here. So this is a LSB and this is a MSB. So moving. So that means when we are performing logical shift right, the LSB data will move out. The LSB data will move out of the register. Then, so it is a D0, D1, D2, D3, D4. These are the bit positions. D6, D7. So these are all the bit positions. So whatever the bit present in D0 position, it will be moved out of the register. Next, whatever the bit present in D1 position, it will be moved to it, or it will be shifted to the D0 position. That means 0 will comes here. Similarly, D2 position will be shifted to the D1 position. So here 1. So here 0, 0, 0, 0, 0. So this 0 is shifted to here. So here there is a vacant position. Here there is a vacant position. So that vacant position we are filling with 0. So we are filling with 0. So after performing shift right operation, what its content is equal to, see here, its content is equal to this one. So before this is equal to 5. This is logical shift right. So this is equal to 5. Next, see, this is equal to 2. So its equivalent decimal value is 5 and its equivalent decimal value is 2. Okay, see. So here in so shift logical shift right. So logical shift right means that is equal to the dividing a number by 2. So here actual value stored in the register is 5. So if we divide the 5 by 2, so you will get 2.5. But here we will not showing any floating values. We will show the integer values. So nearest integer is 2. Okay. So that's why it is showing 2. And coming to the arithmetic shift micro operations. So this arithmetic shift micro operations we are using for signed numbers, signed binary numbers. Okay, that means either we can use for signed. That means we can use it for positive numbers as well as negative numbers also. So there are two ways to implement arithmetic shift. So that are arithmetic shift left micro operation, arithmetic shift right micro operation. First one, arithmetic shift left. So this arithmetic shift left micro operation, it is similar to the logical shift left micro operation. So both are same. Okay, but here this arithmetic shift left, it can be useful for the signed numbers. Okay, so remaining is it is similar to the logical shift left operation. So here already we have seen. So when you are performing shift left operation, that is equal to the number multiplied with the 2. So see here, the binary number that is stored in the register is 00100011. So that means that is equal to the 35. That is equal to 35. So that means 2 power 0, 2 power 1, 2, 3, 4, 5, 2 power 5. So 2 power 5 means 32, 32, 2 power 1, 2, 2 power 0, 1. So total 35. So that means it is the binary representation and 35 is the decimal representation. So in decimal, that is equal to the 35. So after performing the shift left operation, so that means the result is equal to the multiplication of the number with 2. So 35 into 2, so 70. So that is equal to 70. Okay. Okay. So the symbol used ASHL R1. So arithmetic shift left. And coming to the arithmetic shift right. Okay. So the each bit in the register is shifted to the right one by one in this shift micro operation. So here in this, the data present in the register, we are shifting to the right side. We are shifting to the right side one by one. So the least significant bit is moved outside the register. So LSB is moved outside the register, and the MSB, in place of MSB, is filled with its previous value of MSB. So that means here you can see this register. Okay, so this is a least significant bit and this is a most significant bit. So if you label it bit positions D0, D1, D2, D3, D4, D5, D6, D7. So here the D7 is it is a MSB position, most significant bit. So here this MSB, it acts as a sign of the number. So because here in this arithmetic shift micro operations, we are using assigned numbers. So that's why the MSB, it will be used as the sign of the number. Okay, so that's why always the MSB bit is reserved for the sign of the number. So that's why the MSB bit it will be reserved for every time. Okay, so see here. So this MSB, when you perform arithmetic shift right, the MSB bit will be copied as it is. So that means 1. So what is a MSB here? 1. So the same one will be preserved. Next, so D7 position 1 is there. So that D7 position bit will be copied to the, or will be shifted to the D6 position. So that's why here 1. Next, D6 position bit will be shifted to the D5 position. Similarly, all the bits will be shifted to the right side. Okay, so here already D0 in D0 position there is a 0. So that 0 will move out of the register. That 0 will be moved out of the register. So here 1 is there. Okay, so see here. So what is this? So this is a data present in the register. So here what is a sign of the number is 1. It indicates that negative number. So 0 is for positive number, 1 is for negative number. So that means in a register, negative number is there. Negative number. Okay. So negative number is present. So what is its value? It is equal to the 10. It is equal to 10 because this is a negative number. So always the negative numbers are represented in two's complement form. So in order to get its value, first we need to find the two's complement value. Okay, so this is a number. So it is represented. The number is represented in the two's complement. So that's why first we need to find the ones complement. Then we need to add 1 to that number. So see here. So what is the ones complement of the this number? So ones complement is a 0, 0, 0, 0, 1, 0, 0, 1. So this is a ones complement. If you add 1 to that, it will give a two's complement value. So if you add 1, what you will get? You will get 1, 0, 1, 0. So this is equal to, what is its value in decimal? 10. 10 in decimal. So we are performing arithmetic shift right. So shift right means dividing a number by 2. So if you divide the number by 2, what you will get? 10 by 2. So what you will get? 5. You have to get 5 as the result when you shift the data to the right side by 1 position. So let's see, have we got 5 or not? So see here. So here, after performing arithmetic shift right, so the data present in is 1 1 1 1 1 0 1 1. So this is the data. So see here. So for this we need to find the ones complement. What is the ones complement? So 0 0 0 0 0 1 0 0. So after that we need to add 1 because it is a ones complement. If you want to get the two's complement, we need to add 1 to the ones complement. So I am adding 1. So 1. So this is equal to. So this is equal to 0. So 0 1 0 1. So that means this is 2 power 0 2 power 2. So 2 power 2 means 4 plus 2 power 0 1. 4 plus 1 5. So its value is equal to 5. So that means we got the result. So 10. So actual value is 10. So that is divided by 2. So 10 by 2, 5. So we got the 5. Okay. So this is a arithmetic shift right operation. So arithmetic right shift, it divides the number by 2. So already we have seen. So to implement the arithmetic shift right micro operation, we use the symbol ASHR. So when we write ASHR, it indicates that we are performing arithmetic shift right operation. This command means the 8 bits present in R1 register will be arithmetic shifted right, and the result will be stored in the register R1 itself. And coming to the circular shift micro operations. So circular shift micro operations, also known as rotate shifter, moves the bits in the register sequence around both ends, thus ensuring no loss of information. So here in the circular shift micro operation, we will not lose any information or data. Only whatever the data present in the register, it will be circulated. In a circular fashion. And this circular shift micro operations also we can implement in two ways, that is a circular shift left and circular shift. This 0 it will comes to here, and this 0 will comes to here, 0 1 0 1, this 0 here. So after performing circular shift left, so in circular shift left, the data present in register we are shifting towards the left side in a circular fashion. So consider a register, and in this register the value stored is 0001 0100. So this is a data stored in the register. So this data we are moving towards left side. So see here, we are moving towards the left side. So in this way, moving towards the left side. So that means when we shift the data, this MSB data will be comes to here, LSB. So this is LSB. So MSB position data will be shifted to the LSB position. Next, this I am representing bit positions D3, D4, D5, D6, D7. So D7 position data is shifted to the D0. Next, to D6 position data will be shifted to the D7. So that means this 0 will comes to here. This one, 1, 0. Okay. So in this way, all the data present in the register shifting towards the left side. So see here. Okay. So in this way, the data will be shifted towards the left side in a circular fashion. So that means here we will not lose any data. Whatever the data present in the register, it is shifting left side one by one bit positions. So this we are representing with CIL, circular shift left. So R1 tends CIL R1. That means we are performing circular shift left operation on the content of the R1 register. After performing the operation, result again it will be stored in the R1 register. And coming to the circular shift right operation. So this circular shift right operation is similar to the previous circular shift left, except the data is shifting towards the right side. So consider the register with the data 0001 0100. Okay. So here we are shifting the data towards the right side. Okay, towards the right side. Okay. So when we are shifting the data to the right side, this D7, this LSB position data is shifted to the MSB. So this is MSB. So this 0 is copied to here. Next. So this is a MSB. So whatever the bit is present in the MSB, it will be shifted to the D6 position. So this is D